Hello there once again. Welcome back to our Chem 152 video series. In this video, we're doing a problem that uses Henry's law. This question says, in a solution of CO2 in water, the solubility of CO2 is 10 grams for every 4 liters of solution, when the temperature is 10 degrees Celsius and the pressure is 1 atmosphere. The first part of the problem will be to find the Henry's law constant, or K, at this temperature. Now, Henry's law is this equation on the right side. The molarity of the gas that's in solution with the water is equal to K, the Henry's law constant, times the pressure applied externally. You may notice that we did not give you the molarity in this question, and so it may be useful at this point to remember that molarity is defined as moles of the solute divided by the liters of solution. In this case, the thing that we are dissolving is a gas, CO2. So in effect, the molarity is the same thing as this fraction. Rather than saying big M, instead we'll say moles of solute over liters of solution. We'll set this equal to the Henry's law constant K times the pressure. At this point, it may be a good idea to have another look at the question and see what things we know. If we look through the question, you might notice that we do not know the moles of solute, but we do know the grams of solute. Just to remind ourselves of what we know, we'll make a reminder that we know the grams of solute, and we'll make a note that it is CO2. We do know the liters of solution because it's given immediately afterward. We'll place a check mark by the liters of solution in the equation and write down that our liters of solution is 4. Now, the goal of the problem was to find the Henry's law constant, K. We don't know what that is. Box this in red. Put a question mark next to it to remind us that that is our unknown. We also note that we do know the last letter, pressure. That's 1 atmosphere. Place a check mark next to that and write down that we do know pressure. So let's revisit the moles of solute, which I've boxed in yellow. We don't know what that is yet, but since we know grams, we can change those grams to moles. We'll write down that we start with 10 grams of CO2. We'll multiply this by a fraction, where we get out of grams and get into moles. The molar mass of CO2 is as follows. We can say that carbon weighs 12.01, and oxygen would be 16.00 times 2. If we add this together, we'll get 44.01 grams per mole. So we'll place the 44.01 next to grams and 1 next to moles. We do the operation. We'll take 10 divided by 44.01, and we'll get 0.227 moles of CO2. Those moles of CO2 will be placed in the top position in this fraction. Now that we've found what the moles are, we'll put a check mark next to that, and now place the numbers in their correct positions. Moles go on the top of the fraction, divided by liters. We'll set this equal to K, which we don't know, times pressure, which is 1. Let's also remind ourselves that the units on the left are moles over liters, or molarity, big M, and the units on the right, next to pressure, are ATM. First, we'll simplify the fraction, 0.227 divided by 4. We'll get 0.0568 molarity equals K times 1 ATM. Then divide both sides by 1 ATM. So our final answer for the Henry's law constant is that K is equal to 0.0568 molarity per ATM. We will now use this Henry's law constant for the next part of the question. The second part of the question asks, if we reduce the pressure to 3.9 times 10 to the negative fourth ATM, what would the solubility be? Let's put a check mark next to pressure and write down that we know what the pressure is. That's 3.90 times 10 to the negative 4 ATM. We can also place a check mark next to K because we just found what that was in the previous section, and so now we can find molarity. So we'll say molarity equals 0.0568 molarity per ATM multiplied by 3.90 times 10 to the negative fourth ATM. When we multiply these terms, the ATM will cancel out, leaving us with just molarity, and now we place the numbers in the calculator. Our molarity will be 2.22 times 10 to the negative fifth molarity. This molarity we've just found is called the molar solubility. However, we can go one step further and get the mass solubility. To get the mass solubility, we just multiply our molar solubility by the molar mass. So we'll take our answer from the previous step and multiply it times our molar mass, 44.01. We'll get 9.75 times 10 to the negative fourth grams per liter. As an interesting bit of trivia, this pressure I've specified is roughly the pressure of CO2 in Earth's atmosphere. This tells us under Earth's atmosphere, the solubility of CO2 in water is 9.75 E negative fourth grams for every liter of water. Thank you for watching. We'll see you again soon.